All right, our first finalist of the day, the first of three, is AccelerEyes. Welcome, and take it away.
Good morning. My name is John Melanakos. I'm CEO of AccelerEyes, and today I'm excited to be with you to present AccelerEyes and our vision for software tools that address the growing demand for visual computing solutions. So visual computing refers to the market of applications that run on graphics processing units, or GPUs, as co-processors to CPUs for increased performance and visualization benefits. The market for visual computing is an emerging market, and most people are just starting to learn about visual computing. So I imagine many people in the room here really haven't heard about this much, and this will be sort of an educational process. But the major focus behind this market are computer processor vendors. So Intel has 1,200 people building the next generation of their chip called Larrabee. It will come out next year. AMD has a Firestream product line that they're heavily promoting. NVIDIA has a Tesla product line. And here at IBM, there's a Cell processor line. All of these chips are fundamentally different than CPUs and are the next wave of computing technology that you'll see in your PCs going forward. These chips have hundreds and soon will have thousands of cores on them, which is very, very different than dual core or quad core, which you see in your computer today, and offers a lot of benefits to the computing world. The problem with these chips is that they're so different from CPUs. They're fundamentally different in architecture that you cannot, the software developers, the guys that write the applications that you use, cannot take Microsoft's Visual Studio or the open source GCC, these are compilers, they can't use those compilers to run on these new chips. So there's a huge lack of tools in the marketplace. And so our business is to share in solving a piece of this problem by enabling scientists, engineers, financial analysts to run their applications on these new chips. To illustrate this a little more clearly, let me share a few examples and sort of see it from a customer's perspective. One really cool application in the healthcare industry is surgical instrument tracking. Surgeons are looking at ways of doing minimally invasive surgery via having a system in the loop where they can have an imager, maybe an MR machine, which is wrapped around the patient during the surgery so they can actually watch their surgical tools inside of the anatomy via the MR machine. In order to do that in real time, you need a lot of processor power to process those images and to provide the feedback to the surgeon. If you were to put together a system, a CPU-only based system, to do this, it would cost you roughly $64,000. If you have a GPU version of that, you can do it with a 10x cost savings, or do it for $6,400. And that's a huge motivation for the industry, not only for healthcare, but across healthcare, finance, defense, energy, automotive, and communications industries. Basically, anyone doing technical computing is going to benefit from this technology. Let me show our product in an example here of what it does for a customer. Our product takes MATLAB code. MATLAB is the most popular technical computing programming language with 4 million users worldwide. Our product takes MATLAB and enables it to run on these GPUs. On the left, you see MATLAB running on a CPU. At the top, you see the numbers. It's framed per second. It's running at 2 frames per second on a very good dual-core GPU. On the right, you have our software enabling MATLAB to take advantage of the GPU running at 80 frames per second. And you can see sort of the interactivity. That's a 40x speed improvement. That means a scientist that was sitting around waiting for this oceanography simulation to take 2 weeks can now do it in a matter of a few hours, and really represents a huge change in productivity and workflow in getting from point A to point B in terms of scientific results. To look at this a little differently, really it comes down to this graph of performance versus price or cost. GPUs represent the disruption in the way computing is done. In the green, you see GPUs all the way from workstations through high-end data servers with many nodes. In the blue, you see CPUs. Across the board for equivalent costs, you get orders of magnitude, 1 to 2 orders of magnitude increased performance with this technology. Let's look at, for instance, if you are a company or a customer and looking to spend $5 million on your data center, you have two options today. If you put together a CPU-only based system, you could configure something like is shown on the left. If you enhance that with GPUs, still spending $5 million, in the end you get 50% fewer systems with 6 times more performance in a 40% smaller footprint, so your actual size of the place where you have to store this stuff is less, using half the power. So these are all compelling metrics that are driving these processor vendors and the industry in general, the visual computing market, to emerge. And this market is sort of coming from pieces of high-performance computing, embedded software, and just standard PC computing. Sections of all of those markets are coming together into what is being named visual computing. But let me reiterate the problem here. Again, the problem is that you have this great hardware that's emerging, these GPUs, and you have all sorts of really cool applications that scientists and engineers want to develop, but there's a big gap in terms of the tools that the programmers, the guys who build these applications, don't have the tools today to connect a GPU to the applications that they're interested in. Whereas PCs and CPU-based clusters have now had many years of mature software tool development, GPUs still are in their infancy in terms of software tools. So stage one of our business is to fix this problem, to provide, again, focused on MATLAB, the tools that MATLAB scientists need in order to take their applications in whatever industry they may be, financial, oil and gas, medical, automotive, and put those on the GPU to get all of these benefits that we talked about before. That's stage one of our business. Stage two of our business is then to leverage those tools to build vertical suite of libraries and applications that apply to specific niche industries. And so that'll be stage two of our business. So why do customers come to us? Why do they want to use Jacket is the name of our product. Really what it does, Jacket, like I said, is focused on merging MATLAB. And MATLAB is so popular because it's very high level and user friendly. So a scientist can come in, type very high level commands that I want to do this, I want to do that with this simulation. And then MATLAB is able to just run. What we're doing is taking that and merging it with GPUs, with the speed and the graphics capability of the GPU. And so we're taking the high level and translating it down to a very low level and optimized software package. So in the end, it brings together three very important worlds for the customer. So we often get asked, so what's your competitive advantage in this? What's your secret sauce? What makes you unique from the competition? We can talk about this in a few ways. First of all, we have a pipeline of patents that we've submitted that speak to how do you take high-level code and automatically create a low-level optimized system for a scientist or engineer who really needs performance but doesn't want to spend a lot of time muddling in computer science nuances of implementation detail, and they want their code to scale with whatever hardware configuration they may have. That's stuff that we do and we have submitted in our patents. We also have a patent on how do you take computation and merge it with visualization. The merger of visualization with computation is becoming increasingly important for scientists as data sets continue to explode in size. And really, for many applications today, it's only via a visualization that you can actually understand the science behind the scenes. This work, we started back in 2006, and then our company was formed in 2007. We went 2 years in intense R&D from our 4 founders, all PhD-level researchers. It's a high barrier to entry project that we've put together and product that we put together. It's not something that even very skilled other PhD people can put together. It's a really high barrier to entry stuff as opposed to some other consumer applications. The market size, as I mentioned, our business is structured in sort of 2 stages. First, we focus on developers, and then we move over to end users, vertical applications. This market is coming again from aspects of high-performance computing and embedded software. So we took metrics from the high-performance computing industry, from the embedded software industry, coupled those with some revenue data from the MathWorks, who sells MATLAB. And in the end, we came up with the total addressable market for the developer segment. Just for our initial product, the current incarnation of our product is $300 million. and then for the end user market is $1.5 billion. And again, that's just for our initial current incarnation of our product. We have a vision, a strategy to increase that total addressable market with new features and new versions of our product going forward. So there is competition in this space. There are other companies looking to build tools for visual computing, looking to use these GPUs. I show a selection of the competition on this slide, and let me explain the matrix. So in the first column, we talk about an optimized runtime. That's something sort of computer science-y, but really in the end what that means is it differentiates somebody who put together a library of code that may run on a particular kind of GPU or a particular kind of thing, but if you change it at all, it's not going to run. There's a lot of academic projects like that out there, but they're not useful to a real customer. So you have to have an optimized runtime in order for your stuff to actually take hold and to be scalable and useful to an enterprise. Second, MATLAB support, I put that up there because that's where we are focused. That's the highest or the largest segment of scientists and engineers are interested in MATLAB, so we're doing that. And then GPU versus CPU cluster, that's sort of the new visual computing market versus the old way of doing things. So there are some companies looking at GPUs, other companies are sort of still just looking at CPUs. In the end, our technology brings together the world's an optimized runtime for MATLAB and GPUs. It's the only company doing this, and we have a great head start and lead and competitive advantage in this. And as we continue to innovate, we'll sustain that advantage going forward. So how do we sell Jacket? What's our model? We mostly have an online distribution model. Our customers are some of the most technical customers in the world, so they have no problem with coming to our website, learning about our product, downloading a trial version. We offer 15-day trials, and then they can purchase and download. Everything is managed online. We have a very good forum system where people come in and can ask questions and get technical help. That said, we do have many partners who are doing sales. I'll talk about that in a minute. Our software license model is we sell perpetual licenses. That's standard for MATLAB-based products. It's a perpetual license. It doesn't expire. It's on a per GPU basis. We differentiate based on customer type, so we offer heavy 25% or 75% academic discounts. We have maintenance at 20% per year for upgrades, future upgrades. And then we have a slew of other optional upgrades and add-ons that people purchase depending upon the problems they're trying to solve. So how do we get the word out? How do we do marketing? How do we do sales? Really, at this point, we're a small company, so we've been very, very fortunate in landing some very strong partnerships with product partners such as NVIDIA and the MathWorks that really do most of the evangelism for us. They promote us on their websites. They do webinars with us. They do email blasts for us. We also have experienced a lot of targeted free press with trade magazines and scientific journals carrying our story because it's a very hot topic right now. Sales is done, as I mentioned, online, but we've also signed up over a dozen resellers worldwide, which I show in the bottom right. These resellers have coverage of over 40 countries and are doing a great deal of hitting the street with our message, and they're working on 25% commissions. So who are our customers? I just show a cross-section of our customers on this slide, mostly to point out that every major technology company and university and government institution has used Jacket in some way already, and we're in the process of now converting our thousands of users over to paying customers. We released commercially to our customers 4 months ago, and I'll show revenue in a minute. We have a great team. So as I mentioned at the beginning, our team started as 4 PhD-level researchers coming out of Georgia Tech. We came together. We decided this was a very important addition to the marketplace, and we built this over 2 years. Since then, we've hired now 6 more, so we have a team of 10, 6 more developers, all master's level, mostly coming out of Georgia Tech. We have a great board of advisors, including 3 seasoned professionals from the high-performance computing industry and entrepreneurs, mostly located in Boston and Palo Alto. We have 2 local business guys that we can go to for seasoned advice on that side. To show you just exactly what our financials are looking like right now, so this is 2009 cash flow. The first 5 months are accurate. That's what we did. So we released on January 26, 2009. Our first sale was that day, and we've continued to increase month over month more revenue. I think we've hit close to 100K revenue to date, and we expect that to continue to grow as we go forward. Costs are also growing. We, as I mentioned, just hired about 6 new programmers, and we have some temporary summer help, which is bumping up the costs over the summer. That results in this cash flow that I show. And so certainly with the business launch, we hope to win, and with the money, with the prizes, both the cash and the services, we'll put that to good use. We'll be able to do things that we've been neglecting, such as we have a slew of sort of patents that we need to file that we've avoided for cost reasons. We have a lot of market outreach that we need to do. We also have some developer or support infrastructure we need to put into place so that we can handle customer support problems. And finally, we simply need to add new features to our product to continue to grow it and continue to convert our users to paying customers. This results in the 5-year projection I show at the bottom. We expect that we'll do roughly 300K this year based on what we're doing so far. Next year, we're really going to bump that up because we're going to do 3 major releases, which will really open the floodgates for our customers. We're going to release double precision. We're going to release some matrix linear algebra stuff, and we're going to release the ability to run our software across many GPUs simultaneously. Those 3 releases over the next year or so will really bump up our revenue, and so we're projecting $1.5 million for next year. And then our vision will carry us forward. We have great enhancements and additions and sort of new incarnations of the product that we think will take us to saturation and growth going forward in the 5-year projection. There's a few snapshotty things that I want to show here. First of all, we have exclusive founder rights to our patents, so that's important for our business. We have a history of releases and working with customers. We've released now for over 2 years. Back in 2007, we did our first alpha release. Then in June 2008, we had our first beta release, which ran for 7 months until 4 months ago we released commercially. I mentioned the importance of our partnerships. As we continue to move forward, those partnerships continue to strengthen and expand and really make for a compelling sales and marketing side of the business. Also, very early on, how did we fund this to date? We landed a $210,000 grant from Emory University from the NIH, which fueled our research and development to date. That money's gone, so now we're purely revenue-based, running off of revenue. I did mention that we would be able to use the business launch winnings very wisely, but that we're not pining all of our hopes on that. We also are we're closing a friends and family round right now. As was mentioned in the panel this morning, we have 6 major defense customers: Lockheed, Northrop, SAIC, L3, Raytheon, and BAE Systems, who are all looking to do partnership level, give us upfront money in return for some tailored development type things. So we're doing that as well. And finally, we've submitted SBIR grants. We have a grant with Ohio Supercomputing that will is several hundred K that will come in starting next year. So we have several other sort of avenues of funding. I want to close here with just one more simulation of our product in action. So often scientists, one of the most common things they like to do is just plot the results. And so often they have thousands of sensors tied to some organism or some mechanical system that they want to analyze and see simultaneously. If you try to push just as many plots, simultaneous plots as you can on the CPU, you can't even get up to 100 before the thing just crashes. I mean, it's just simply incapable of running that much. On the GPU, we're going to get up to 1,000 plots. They're all interactive, moving simultaneously with no problem. And since it's a co-processor, it means the CPU is still free. You don't experience any sort of stalling of your computer because of this simulation running. And again, the difference in frames per second is 0.5 to 50, so 2 orders of magnitude difference there. And with that, I'd like to close. I appreciate your attention, and I'd like to invite my team. I have a great team here. Gallagher, Pryor, Tosif Rehman, and Britt Chapman are all going to join me on the stage for the Q&A portion.
Great. Thank you very much.
Thank you.